Okay, ladies and gentlemen, welcome to the video notes for Chapter 4, Section 2, entitled Angles of Triangles. It's referring more specifically to one specific theorem, which is an extremely important geometry theorem, the triangle angle sum theorem. The angle sum theorem itself can actually be expanded out to cover other polygons, but this theorem is almost entirely, I mean the word triangle appears in the name, is specific to triangles, three-sided polygons. Okay? We're going to expand this theorem out later on to cover all polygons, but for now we're only focused on triangles. My honors students have already seen a proof of this theorem, but there will not, I might do a separate video where I prove this theorem, but I'm not going to be putting a proof for this theorem up on YouTube just yet. This theorem is relatively simple. It says the sum of the measures of the angles, the three angles in any triangle, must always equal 180 degrees. So in this particular picture, the measure of angle A plus the measure of angle B plus the measure of angle C must be 180 degrees. This theorem is relatively easily proved using alternate interior angles and the parallel postulate from Chapter 2, Section, I don't even remember, 2? Yeah, Section 2. Chapter 3, Section 2. Okay, but that proof may come later. We'll see. For now, I'm just hoping that you're willing to take my word that this is always correct. I will at some point provide a proof if you need to see one. Okay, so that rule combined with the vertical angle theorem, which says that vertical angles are always congruent, and the supplement theorem, which says that linear pairs always add to 180 degrees, can be combined into problems like the one that is currently on the screen, which asks us to find the measure of each numbered angle. It's worth noting that in this case, we can find the angles in order, but that will not always be the case. We will not always be able to find angle 1 before angle 2 and angle 3. In this picture, the only angle that we could not start with is the measure of angle 3. At this point in the problem, we do not have enough information to find the measure of angle 3. So we're going to solve these in order. We're going to start by finding the measure of angle 1. We're going to do that using the supplement theorem, which says that since these two angles, angle 1 and the 57-degree angle, form a linear pair, that the measure of angle 1 plus the measure of angle 50, or the measure of 57 degrees must add up to 180 degrees. They form a linear pair, so they must be supplementary. That gives us a one-step equation to solve for the measure of angle 1. We simply need to subtract 57 from each side of that equation, which would give us that the measure of angle 1 is 123 degrees. So then we can label measure or angle 1 as being a 123 degree angle, and we can write that number 123 in our answer slot. For the measure of angle 2, we're going to use the angle sum theorem for triangles, the one on the previous page, and we're going to apply it to triangle LKM. That triangle, we know two of the three angles, which means we can set up an equation that says that the measure of angle 2 plus the 57-degree angle and the 71-degree angle add up to 180 degrees because those three angles form triangle KLM. From there, we would just simply be combining like terms to give us that the measure of angle 2 plus 28 degrees equals 180. Make sure I did that right. Yep. And then we would subtract 128 degrees from each side of that equation, which would give us that the measure of angle 2 is equal to 52 degrees, which we can then write in the answer slot, and we can write on our picture, allowing us to use it if we wanted to find the measure of angle 3. The measure of angle 3 is also found using the angle sum theorem. There are actually two different triangles that we could use. I'm going to use the smaller of those two, which is triangle JKL. In that triangle, we have that the measure of angle 3 plus the measure of angle 1, which we already found as being 123 degrees, plus this 28-degree angle form a triangle, which means they must add up to 180 degrees. Same two steps as what we used to find the measure of angle 2. We're going to combine like terms, which would be the measure of angle 3 plus 151 degrees equals 180, and then we're going to subtract 151 degrees from each side. That would give us that the measure of angle 3 is equal to 29 degrees. Again, we could then write that here. We could even write it in our picture, allowing it, if necessary, to find any additional angles. Now we're going to do one more example on this video, then we will end the first of 3 videos for this section. Again, if you think you've got some sort of grasp on this, you should pause the video at this point and try the next example before I start it. Okay, on the next example, same idea. We've got 3 numbered angles that we need to find, angle 1, angle 2, and angle 3. We do not have enough information yet to find the measure of angle 1. So again, it's very important that at the beginning of these problems you ask yourself, what angles am I able to find? Because right now you're only able to find the measure of angle 2 and the measure of angle 3. So it doesn't matter which one we find first. The measure of angle 2 is probably the easiest one to find, so let's start there. The measure of angle 2, we're going to apply the vertical angle theorem, which says that these two angles here, angle 2 and the 78-degree angle formed by angle ACB, are congruent, which means that the measure of angle 2 has to equal 78 degrees. We don't need any more justification than that to state that angle 2 is a 78-degree angle. The fact that we've named the vertical angle theorem, that we named dropped that, is more than enough information. So then we can either find angle 3 or angle 1 next. It doesn't matter. Let's go ahead and do them in order. For the measure of angle 1, we're going to use the angle sum theorem on triangle DCE. In that triangle, we have that the measure of angle 1 plus the measure of angle 2, which we've just said is 78 degrees, plus the measure of angle D, which is 61 degrees, is equal to 180. We had a problem just like this a minute ago. We're going to combine like terms. The measure of angle 1 plus 100 and, 39 degrees equals 180. Then we subtract 139 from each side to solve for the measure of angle 1, which is 41 degrees. Okay, so then we're going to move on and we're going to find the measure of angle 3. For the measure of angle 3, we're going to use the angle sum theorem again. This time on triangle ABC. In this particular picture, the measure of angle 3 plus the 20-degree angle at angle A and the 78-degree angle formed by angle ACB, those 3 angles together form a triangle, meaning they add up to 180 degrees. Same exact work, combined like terms. The measure of angle 3 plus 98 degrees equals 180 degrees. Then we simply subtract 98 from each side, which gives us that the measure of angle 3 is 82 degrees. And I know that doesn't look like an 82-degree angle, but we never ever trust the picture. Never, ever, 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 ever. Okay, so that does it for the first video for section 2 of chapter 4. Our next video will cover some additional examples, including a couple of SAT-style questions based on the angle sum theorem. And then our third and final video will cover the exterior angle theorem and its proof. Thank you very much for your time.